Problem number 10. This probably should have been an always, sometimes never for our work, but we're supposed to prove that if A has an inverse and beta is not equal to 0, then the inverse of beta times A is 1 over beta times A inverse. Well, we know we need to show two things. For this to be the inverse of beta times A, we need to show first, or one of the things we need to show is that if we take beta times A and we multiply it by 1 over beta times A inverse, that gives us the identity. But we also need to show that if we take 1 over beta times A inverse and we multiply it times beta times A, we again get the identity. So let's see what we can do. The first step, beta times A times 1 over beta times A inverse. Now, this is actually equal to beta times A times 1 over beta times A inverse. But 1 over beta is just a scalar, and whether we multiply a matrix by a scalar on the left or right doesn't make any difference. In general, matrix multiplication is not commutative, but scalar multiplication is. And so this is equal to beta times 1 over beta times A inverse. But we can regroup. This is beta times 1 over beta times A inverse. But beta times 1 over beta is 1, and A times A inverse is the identity, and 1 times the identity is the identity. So clearly, in one direction, the product is the identity. If I multiply 1 over beta times A inverse by beta times A, using the same kind of techniques, I can regroup, and this is equal to 1 over beta times A inverse times beta times A. But again, beta is a scalar, so this scalar multiplication is commutative. So this is equal to 1 over beta times A inverse times A, which is 1 over beta times A inverse times A, or 1 times the identity, which is equal to the identity. So it is true that beta times A inverse is 1 over beta times A inverse if beta is not equal to 0 and A has an inverse.